In this video, we'll be looking at the discriminant. So the discriminant allows us to work out how many x-intercepts there are for a quadratic function, and equivalently, the solutions of a quadratic function when it equals 0. So assuming we have a quadratic function here, so ax squared plus bx plus c. Then, using the discriminant, we can work out how many x-intercepts, how many solutions or x-intercepts there are, and then the solutions for when it equals 0. So the discriminant is equal to, with regards to value, it's equal to b squared minus 4ac. And you work out the value, and then depending on the value, it'll tell us different things. So quickly looking at a graph, then if a quadratic looks like that, then obviously there are no x-intercepts. And using the discriminant, we'll be able to tell that. There could be one x-intercept, or there could be two x-intercepts, such as that one here. So here there's two, this one there's one, this one there's none. So the three different options we need to encounter. The first is that there are two x-intercepts, the second is that there is one, and the third is that there is none. But we need to first understand, where does this formula come from? If you remember the quadratic formula, x is equal to negative b plus or minus b squared minus 4ac over 2a. And you should see straight away that the b squared minus 4ac comes from the inside of the square root bracket. And this tells us that the x-intercepts. So the reason why the discriminant has different values is that if it's negative, then you can't have a square root of a negative number. So therefore, as there's a square root of a negative number, the x-intercepts are not defined in the real domain. So we can say that when the discriminant is less than 0, there are no real solutions. What happens when the discriminant is equal to 0? Well, if it's equal to 0, then that means that the x-intercept will just be negative b over 2a, because the square root of 0 is just 0. And then plus or minus 0 isn't going to affect the answer, so it's just going to give us one answer. So there's one real solution. And that is when x is equal to negative b on 2a. The other option is when the discriminant is greater than 0. And so this is when there are two real solutions. Now the discriminant is useful with regards to just calculating working out how many solutions there are, but also particularly for worded questions, as when you start to see scenarios in which you have to change a quadratic function where there's an unknown variable, let's say b, so we don't know what b is equal to, and there has to be certain conditions defined, such as, let's say this is a pit of lava or something like that, and then this is Tarzan swinging on a rope. Then obviously he can't swing into the lava, so therefore we may have to restrict b to make sure that the quadratic function does not dip into the lava, for example. So make sure you understand, as well as know and memorize, the three different options for the discriminant, and understand that it does come from the general quadratic formula, which you also do need to know. So looking at an example where we have to use the discriminant in a worded question, as I was mentioning before. So we have the trajectory of a submarine is governed by y is equal to kt squared minus 6t, where y is equal to 0 sea level and t is equal to the time. So if the submarine can't go lower than 5 units into the water, what is the value of k possible? So it's not the best sort of question with regards to it's missing a few things, but it's saying that just t is time, it's governed by this equation. So if we have a graph here, and then it's going to look something like this, in which it's coming down, y is equal to 0 sea level, so that means all this area here is water. So obviously a submarine, once it reaches the top, it may just stop there. It's not going to flow, it's going to the sky. But we're talking about here, this is underneath when it's going underneath the water. But it's saying it can't go lower than 5 units. So there is a maximum here of 5 units. A quick thing I will point out, if t was referring to time, then we wouldn't have to worry about any of this area, as that is when t is less than 0, which does not occur. But it can't go lower than 5. So what we're trying to find is that we have this equation, which looks something like this, and we need to find, it's saying what is the smallest value of k? So what is the smallest value of k? Well, what happens when k is large? So y is equal to, let's say 6t squared minus 6t. Well, that is equal to 6t, t minus 1. And that means that the x-intercepts will be at t equals 0 and t equals 1. And the low point will be less than 5 units. You can graph that and you can see that. So the larger the value of k, the summer end goes less deep, or it goes shallower. So we don't have to worry about the 5 units. But when it gets smaller and smaller, it starts to go deeper and deeper. And if we just let k equal any value, then we'd have graphs in which it goes a lot lower than 5 units. So we have to find what is the smallest value of k possible, i.e., this is asking, so like, what is the projectile equation when it just touches 5? So it can go no lower, it can't go lower than 5 units, but it can go, let's say it can go to 5. So we want to find the equation when this value here is 5. If we just go into our calculator and we go solve k t squared minus 6t is equal to negative 5. Notice how it's negative because it's lower than 5 units, and 5 units is into the water, it's going down. So k t squared minus 6t is equal to negative 5, and we solve that. Well, we can't find a value for k, we'll get it in terms of t because t is changing all the time. But what we can do is we can solve this question using the discriminant. So I'll just leave the equation there. So k t squared minus 6t, and we're trying to find negative 5. But why I say we can use the discriminant is if we have a graph here, then effectively we'll say this is y equals negative 5. And we want the equation to go down, touch it, and come back up. i.e., we want this value here just to touch once, or there is one solution at y equals 5. So there is one solution. Now we have kt squared minus 6t, and we know how to work out one solution or two solutions when y is equal to 0. That's just the discriminant, just straight off. But that's not really useful to us because we don't care about how many solutions there are at the x-intercept. We care about this one down here. But what we can do is we can let it equal to negative 5 plus the 5 over, and we can suddenly work out the number of solutions by using the discriminant of this value here. And notice how this equation is slightly different, as now it has plus 5, and this one we didn't have before. So this will tell us the number of solutions, the discriminant of this will tell us the number of solutions for this value. So discriminant is equal to b squared minus 4ac. So that is equal to 36 minus 4 times 5 times k. So it's equal to 36 minus 20k. Now we want one solution, i.e. we want the discriminant to equal 0. So we want the discriminant to equal 0. So therefore, we just solve for 36 minus 20k is equal to 0. And we find that k So 20k is equal to 36. So k is equal to 36 on 20, which is equal to 18 on 10, which is equal to 9 on 5. So therefore, k is equal to 1.4. So the minimum value of k is 1.4. And that's the minimum because if it had two solutions, then it would be too far down. And if it had no solutions, then it wouldn't be the minimum value of K, even though the submarine would still satisfy, as it wouldn't go all the way 5 units down. So the minimum value is when K is equal to 1.4. And that just shows how discriminant is useful in these worded questions.